Hi, everyone. I'm calling this class or this session, the best way to learn is to do it. And you'll see this in other places where the best way to learn to build a robot is to build a robot. Excuse me, the same thing goes for programming. So, what we're going to talk about is the simulator. As far as I'm concerned, one of the most important tools in an engineer's tool belt is the ability to build or to use prototypes. Well, in a programmer's world, that relates to a simulator that simulates some or all of the robot that we're intending to build. And LabVIEW does a nice job of giving us examples of how to use the code. So what I'm doing in this session is walking through an examination of one of the simulator projects that's in the 2019 version of FRC LabVIEW. The point being that every year they have some number of simulators that are worth looking into, even as you're just learning to program in LabVIEW. So what I'm trying to do this with this episode or this session is to tell you what to look for. So the example that we're going to look at is called the ball shooter simulator. The tele-op drive control is arcade. I'm going to be using or building an autonomous code that'll use tank drive. I'm also going to be using the encoder to measure the distance traveled, the gyro to measure the turn angle, and I want you to make sure that you see where I put all variables through the robot global data. And then I'm going to spend a little bit of time talking about at least what my critique of the ball shooter, not in terms of how clever the design is, but how difficult it is to do, in particular, to do autonomous control. So the goal for the autonomous code that I'm going to be writing is going to have 6 steps in it. We're going to initiate, then we're going to turn the robot 90 degrees to the right, go forward 50 inches, excuse me for my hiccups, and then try to shoot the ball twice. And the first thing you're going to see me do as I open up this project is to look at the README file, which describes where all the channels are located in this simulator. Now, as we look at begin.vi, it already has the gyro set up, and so the only thing I need to add is the encoder. It's got 2 encoders, you'll notice, so I'm only going to use the one, and it simplifies the design, but it makes it relatively easy in tank mode because you should be driving both sides the same direction at the same time. And then I'm going to discuss how they use tele-op, which is difficult because it's not something that's active during autonomous. And then some of their controls are in periodic task. And then we're going to show, I prefer to use the encoder versus sonar, primarily because sonar has some drawbacks if the robot's working on its own, if it's an autonomous. For instance, it can't tell if something moves in front of the robot as it's measuring the distance, whereas the encoder measures the exact distance that the robot has traveled. And so we have a better chance of ending up where we want to be, especially if something got in the way. Anyway, we'll talk more about that as we get into it. Okay, so we're going to start with an FRC robot project, and we're going to use the ball simulator simulation, the ball shooter simulation. So as the new LabVIEW versions come out, they will probably have some changes as far as the different simulators they have. And frankly, it's worthwhile going in and looking at it. So I'm going to go ahead and open up LabVIEW and show you how this stuff goes. So we're going to start with the new robot project. We want to give it a name, and so in this case I'm going to call it, and I want to be near the top of my list. So 02 Sim Ball Shooter. Need to put in the team number. And then select the ball shooter simulation. Now it's going to build the project, and it's going to open up the Project Explorer. So in the Project Explorer, there's two things I want to look at to start with. First of all, we're going to expand team code, and these are the VIs where we will change the code. First thing I want to look at is, though, the robot simulation README file. So this is an HTML file that gives us all the channels that are being used by this particular program and that are available for us to use. We're not going to worry about the servo or camera servo. We are going to use a left encoder, which is on channels DIO 5 and 6, and we are going to use the analog channel. So I'm going to park this right here, and we're going to go in and look at what channels they've got set up. Begin is where you set up all the channels for the project. And here we can see they've got the drive motors already set up. They've got the USB joystick set up. They've got a shooter motor, a shoot servo, an agitator servo, which are all beyond things that I want to control. Here's the gyro. So the main thing I want to look at is the way that they've built the name into this particular channel. So it's all lowercase gyro. And like I say, they don't show the encoder. So I'm going to open up an encoder channel. I'm going to right click, go to my actuator, excuse me, it's a sensor. So go to my sensor panel, the encoder, open, and then assign a name. Now again, it uses two channels, digital I/O channels, and the one I'm going to be on the left motor. So it's A channel goes on DIO 5, and the B channel goes on DIO 6. Now when we only have the one type of sensor, we don't have to give it a unique name. So in this case, I'm just going to right click here and say create a constant. And because this is the only one, I'm going to let that be the name of my encoder. Okay, now normally I go into finish and close all this, but because let's just show you where this came from. So I'm going to close this and save, go into finish. Now for some reason in the simulator, they don't have to close all these channels, partially because it's not a real-time operating system. But if we were writing this code for a robot, we'd have to close all those channels that are open. So I'm not going to worry about that for now. Okay, so we've got begin open. Now I want to go in and look at each of these VIs. So let's start with tele-op. Now, as I mentioned before, tele-op is what usually it's where they usually have their drive control, excuse me, and it's over here on the other screen. So let me drag it over. Okay, so this is where they take their drive motors and they control arcade drive with the joystick, the X and Y axis. And you can hover over this and you'll see this is the X axis and this is the y-axis. So it gives us a clue, the order of the axes that are coming out of the joystick array. And then there's some other stuff here for buttons and speed control that I frankly don't understand. And the problem with putting these functions in tele-op is they're not available to autonomous control. So what I'm going to be doing is, because this is not used or open in autonomous, I'm going to be doing something different in autonomous to control the motors for right now. So that's begin. And if you look at some of the rest of my videos, you'll notice that I literally disable all this in a normal project. And you'll see me do that frequently, just not on this particular simulator. All right. So I'm going to save the tele-op changes, which were not any changes. I'm going to look at periodic task. So periodic task is what's usually used, set your controls. And if we look at what they've done, they don't have anything in their first loop. They do have the joystick here and the pipe, but nothing's going on with the drive motors. Here we take a joystick button that controls motor output for the scoop intakes on the simulator. Here's where they're reading the distance on the sonar. Here's where they're reading the orientation or angle on the gyro. And this is a value that I want. All the values that I want to use are going to be coming or run through Robot Global Data. So the way we pick up that is we come back to our Project Explorer, select Robot Global Data, drag it into our block diagram, and double click on it, and it opens up the front panel of Robot Global Data. So I want some variables. I know I'm going to want a auto left drive, and I want an auto right drive because we're going to be doing things in tank. And I'm always using an indicator, so in this case a numeric indicator. And spelling doesn't matter. Okay, I also want the gyro value. So we're going to right click, put in a numeric indicator for gyro. And I also want one for the encoder. So let's put another one. Okay, once I've made all those entries, I'm going to close and save. And now I can pick up in Robot Global Data that particular variable, and I want to hook it to this number that we're getting from the gyro. Now we're not showing so I'm going to do another while loop for my encoder, just because we're going to make it in a while loop that's going to run forever. We're going to pick up my encoder, and then now because we're going to be moving the wheels, we're going to want to reset before we measure how far we've driven. So I'm going to get the value, and then at some point in time allow it to be reset. And I'm going to use the same, if you remember, the same variable name that's default. So now it's going to pick up my encoder reference, and over here I'm going to put I want a copy of my Robot Global Data. And this is where I'm going to store the encoder. Now, just a little side diversion here. Because the encoder can go positive or negative, I always want to use the absolute value. So I use the absolute value from the numeric palette, and then this is taking the distance and putting it into the encoder. Now, to reset, if we come back here and pick up a case structure, when it's true, I want to reset the encoder. When it's false, I don't want to reset the encoder, and I want to take it straight through. So the question, what is it? What's going to control this case? And this brings me to another value that I want in my variable list on Robot Global Data. So I'm going to hold down Control, take a copy over here, and open this up. This is going to be auto reset to reset the encoder. Actually, I will also use it to reset the gyro. So I'm going to save this, change it to a read, change it to auto reset. Okay, so now when this is true, reset the encoder. When it's false, it reads the encoder to Robot Global Data. This puts me back to my gyro angle, and I'm going to put a little room in here by holding down Control. And we're going to do the same thing. I'm going to put a case struct here. And inside, I want to put my reset. But I need to use the gyro reset, so come down to my sensors. Gyro reset. And now when that's true, it'll reset the gyro for me. And when it's false, we want to connect it straight through. And I'm going to use the same auto reset variable. Let's bring this around, change it to read, auto reset. Now as I do this, you notice I've grayed out my run arrow, and when it says what am I doing wrong, it says, well, you're missing an assignment to one of the tunnel variables. If I say show me, it's because I haven't connected these here. So now I'm back. So now with an auto reset, I'm going to reset the gyro, and I'm going to reset the encoder. Okay, now, so a couple points I've been trying to make. Whatever's being used in tele-op is not usable in my Autonomous. And so I'm going to go to Autonomous and set up my code for running Autonomous. And the problem is going to be I don't have a way to control the chute mechanism. Okay, I'm going to take these out. Now again, I'm still in the project for the ball shooter. I want to set up 2 while loops. Part of the reason for doing it this way is you need to update the controls to the motor every 100 milliseconds, or the computer or the robot will shut down. And so I'm going to set up my control. This is where I want to look at tele-op. Okay. What I want to do is construct this exact same combination in my Autonomous. And I don't want to do copy and paste because I'm not sure what all is going on here. So first of all, I'm going to open a motor under drives, not under actuators. So let's go ahead and do that. Under drives, pick up the channel, and then I'm going to use tank instead of arcade. So back under my drives, tank drive. Now the reason I wanted to open this up is I want to use exactly the same values for the channel name. So if I come back over here, right click and create a constant, and then paste in there what I just copied over, I have exactly the name from here. Now, let's go back to my robot global data. Now, what's going to control my tank drive now is going to be my auto variables of a left drive and right drive. So at auto left, hold down control, left click and drag, auto right. And if I hover over this input, I can see the left is the top one. And the second one is my right. So now, how's this going to work? Whatever value is in here is going to be written into the tank drive control. It's not going to bother anything here because this tele-op is not active during autonomous. So I need to have a wait. Always want to have a wait time during a while loop. So I'm going to enter a constant. We got to run it inside of 100 milliseconds. So that's set it up for 75 milliseconds. And now here's another trick thing that I wanted to do. I want this to be deactive. I want this loop to stop whenever we're no longer in autonomous. So I'm going to take a copy of robot global data. I'm going to pick out robot mode. And I'm going to pick from my comparison palette not equal to. So when this is not equal to autonomous enabled, I can create a constant and it knows what I'm talking about. So I want to pick out autonomous enabled. When this is not equal to autonomous enable, I want it to be true. And so that's when it's going to stop the loop. When it equals autonomous enable, it's going to be false and the loop will run. Okay, that brings us back to what we're going to do for here. So I'm going to make myself a little bit of room and put in a flat sequence structure. And let's go ahead and make some room while we're at it. Okay, now, I don't know if you've seen one of my videos that we talk about this, but essentially I'm going to just do 4 because I don't have control over the shoot button. Okay, next I want to put all my auto controls up here. So I'm going to take a copy of change it to right, the auto left drive. Now I want auto right drive. And I also want to have auto reset. Now, I want to have something controlling. So for my initiate, I also want to set up another variable that's a string value, a string indicator, and I want this to be my auto step. So under autonomous, which step am I in. So this is a good way to keep track and then debug what we're doing. So this first step I call initiate or init. And so I want to create a constant. And this will be a string, so it's init. I want to zero everything out, so I want to start off with a constant 0 for my drive system. And I want true on my auto reset because I want to reset both the encoder and the gyro. Now the question is, how long do I want to do this for? And let's say I want to do it for half a second. So I'll put in a while loop. The while loop has a time delay of 10 milliseconds. And so it releases the microprocessor every 10 milliseconds to do other things. And to get a half a second, I need to run this for 50 loops. So this loop counter down here, we're going to say when it's greater than or equal to 50, we want to stop this loop. So the loop counter, and then a constant on the bottom, set to 50. So again, 50 loops times 10 milliseconds is 500 milliseconds, and that's what will stop and then move to the next stage. All right, so that's how this first frame is constructed. So I'm going to left click and drag and select all of this, hold down Control, drag a copy into here, drag a copy into here, drag a copy into here. Now, just like the Coke machine where I'm selecting buttons on the front, I'm going to be changing my variables up here so that different things will happen. So the next step is a right turn. To turn right, I need my left drive motor to go forward. So that takes a negative sign, a negative signal. So this will be a negative 0.6. And my right drive to be reverse, so it needs a 0.6, a positive signal. And at this point, I want not my loop counter, but I want my gyro signal to be 90 degrees. So let's set this up for 90 degrees. Let's pull down one of these robot global data. I don't want to take it. I want to take a copy of it. Change it to write or to read. Make sure it's my gyro. Okay, so this step with these motors turning in opposite directions will continue until the gyro angle is 90 degrees or greater. And then we go to the next step, which is rest or reset. I want everything to stop, and I want to reset both the gyro and the encoder. So we want to do a measured run. And then we're ready to go to the next step. I'll make some more room here and add another section. Okay, so I'm going to stop, and I only really want to do this for 100 milliseconds. And that is stop the wheels and reset everything. And I'm going to take a copy of this. Hold down Control, move everything over here. Now I want to drive forward, so my Control signals ought to be negatives number, so I'm going to use negative 0.7, negative 0.7. And because we haven't calibrated our encoder, we're going to just use some big number until we know how many clicks it is. But 360 clicks per revolution. So let's do 3,000 clicks. What we're counting on our distance from our encoder, we're counting the pulses out. We haven't calibrated it for inches yet. So let's say this is going to be 3,000, which ought to be 10 revolutions of the motor. And we want this to be our encoder. Now the encoder was reset in the previous step, so it starts at 0. We need to undo the reset and what have I done here? I want to reset here. Oh, I jumped ahead of myself. So we need to forward here. So we're going to go forward. This is where I want my negative 0.7 and a negative 0.7. And not going to reset anymore. And this is where I want my encoder to be reading out. And so the way you get rid of broken lines is Control B. So Control B will get rid of all that stuff. And I want this to be 3,000 down here. Sorry for messing that up, but it just shows to go, yeah, you got to be careful even if you've been doing this 100 times. Okay, so I'm going to initiate everything, zero my motor, reset the encoder and the gyro, then release the reset, go forward on the left drive, reverse on the right drive, turn right until my gyro is greater than 90 degrees, stop everything, reset again, then release the reset, go forward for 3,000 pulses, and then over here I want to stop. I don't want to reset. I do want my string to say stop, and I want to do this for 1 second. So let's create a constant that's 100. And look at the loop counter. Now, you'll notice, so I'm happy with my code, but I have a negative run arrow. If I look at it, it says the while loop is not wired. If I look at that, it's because I haven't done anything to control this. And so what I want to do is create a constant here. And it gives me F, which is a false, and will run forever. But I want it to stop whenever this loop finishes. So I'm going to drag this inside. And now when this loop finishes, it'll stop this, this particular frame. Okay, so everything's good here. I'm going to save it. Hopefully you've been able to keep up with me. Now we're going to run the simulator. We're going to save all of our example and see if we can make this happen. All right, so let's get rid of this guy. Let's open up our, and we'll be doing more webinars on this after the start of the season. Again, let's start with our driver station. And we're really not going to be using the dashboard. We want primarily. And again, if you haven't used a simulator, by all means, spend some amount of time so you can master it. We always start any robot program with robot main, and we run it. And if we've done everything correctly, it'll open up the simulator window. We want to slide in and look at the side. Now, if you'll notice, I've got my joysticks connected. If I go into tele-op, and well, before I do that, let's go back here. I want to look at my robot global data. And I do that by double-clicking robot global data here. This is extremely valuable for troubleshooting. So here we're sitting, we can see the gyros running, the encoders running. We have 0 on our auto left and right. We have nothing on our reset. So I'm going to be enabling tele-op. Now you can tell, actually before I even get there, you can tell if I go back to my USB that I have the controller set up for USB 0. And when I move the axis, the joystick, I get full forward, I get a y-axis. L is a negative, full forward, back. The y-axis is reverse. I get a positive. If I take it all the way left, I get a negative. If I take it all the way right. So this tells me the values that should be applied to my motors. Okay, so I can tell the joystick's working. I'm ready to go to tele-op. We enable it. Now let's look at our robot global data as well as our display. Now again, the gyro, I'm going to go back here. You can see my encoder goes positive because I have absolute value. When I turn in circles, my gyro goes all the way around. Okay, so autonomous seems to work fine. Now we want to see what, tele-op works fine. Now we're going to do autonomous. And what we should be looking at now is our auto controls. We start out with an auto reset, and then we go turn. We should see the gyro 0 out, and then turn until it gets up to 90, and then it'll stop and go forward. So let's see if it works. So there's a reset. There's a turn. There it gets up to 90 right there. It reset. Now it's going forward up to 3,000. Looks like it's going to run into the wall. There's 3,000 and it stops. I'm impressed. I've impressed myself here. I'm going to back up. Let's try this again. So I want to start this direction. Okay, autonomous, enabled, turns 90 degrees, resets everything, starts going forward, encoder's getting up to, and you can see it's going basically straight because the left and the right are going at the same speed. And here's 3,000, it stops. Now you may say, well, Jim, why aren't you shooting? And the reason is the shoot mechanism is part of the tele-op that they didn't set up to work during autonomous. So that's my critique of the simulator. So let's look at a couple other things. Because this is an older loop, very often after you've run it a couple times, it crashes LabVIEW. And so, in fact, I do want you to see this. I'm going to close it. It's going to say, do you want to restore it? I'm going to say no. Go ahead and close. It's going to shut everything down. And then what I'm going to do is just open it back up and then recover the program. And so I want to talk about this a little bit more. I don't want to do this, but I do want to recover this. All right. So I want to talk a little bit about the construct. And again, the next generation or the next season's LabVIEW may not have this particular one. But if you're going to be trying to make it run and copy some of the constructs that they use, it's useful to know what works. And look at some of my videos on perfect autonomous, because that's what I do is I switch all controls from tele-op to autonomous, but I do it in periodic task. And the reason for that is periodic task runs all the time, whether you're in tele-op or whether you're in autonomous. And so any controls that you need to use, you want to really set them up in periodic task. So just a couple critiques here. Here they set their agitator, they set up in periodic task. The sonar they've set up to read. The intake scoops they set up to read. What's not here is the shoot button. And so these will run as you see them run in autonomous. And in fact, it's pretty clever how they do it. But if we come back and look at tele-op, this is where they're controlling the motors, but they're also controlling the chute. And the reason, I'm sure the reason they do this is they didn't expect anybody to do it on autonomous. But it's a clever design, and what it basically boils down to is they have the shooter motor running full time, and then they flip a servo back and forth to deliver a ball to it. So it's a clever mechanism. In fact, it's worth looking at from while we're in tele-op. So let's just go ahead and do that. So I'm not going to be running autonomous. We're going to be running tele-op, and we're going to be seeing how this thing works. All right, so let's go back to our dashboard, driver station, go to tele-op, enable it. All right, we can see as we turn this around, the little wheels there are driving the scoop in, and then these two wheels down here are the things that provide the impetus to throw the ball out. And if we flip the switch, you can see it. There's a servo back underneath here that goes back and forth and delivers a ball to the shooting mechanism. And then the agitator is supposed to be doing something to the balls inside. At any rate, it's a pretty clever design, and it works really well in tele-op. It is just difficult to transfer these controls into autonomous. Okay, fun to play with, and I invite you, like I say, to try it if you have the last year's LabVIEW. If you don't, wait till you get the new installation and see what simulators they've given us for next year. Okay, a couple things I wanted to touch on before we close this out. Appreciate you guys hanging in there with me. And it really boils down to things that you need to think about ahead of time. It's a good idea. In fact, more than once, I have had to stop my installation and uninstall all old versions of LabVIEW before I try installing the new version or for the new season. LabVIEW installation takes anywhere from 2 to 3 hours. And then after installation, you have to do a mandatory utilities update. And from there, look at the examples that they've given us, because that'll give you a clue as far as what new sensors or actuators we have. And then take some time to look at the simulators. So these will be under the robot projects. And you'll notice even in this year, they had special dashboards to show you how the ball counter worked in that ball shooter simulator. So there's a lot of good information and a lot of things to look at to try to understand how that simulation code works. Make sure you check out the README file to see what peripherals are being used. And the goal is really to have this information as you're working with the team to determine what the new design for the new game is going to be. And as everyone else is looking at mechanical operations and mechanical motions, what you need to be thinking about as a programmer is what sensors and what actuators would be needed to support that element of the design. Whether it's limit switches, whether it's encoders, whether it's sonar, you need to comprehend what the design will require to facilitate the motion that's being part of the strategy. Now, if some of this stuff is unfamiliar, you need to start thinking about playing with it to make sure you understand how to implement it. And you can do that in the simulator, as we've just done, or have the team build you a proto board, especially if you're going to be looking at pneumatics and compressors. Set up a proto board where you can play with it and understand how actuators work, how solenoids work, before you ever get the robot project even built. So again, that's what you need to be thinking about, even as they're talking about the strategy for the game. Good luck heading into the new season. Frankly, if you have questions or need ideas to bounce off of somebody, you're more than welcome to shoot me an email and let me know what you're trying to do. I can't say I have all the answers, but I've certainly made all the mistakes. So I can share with you what my experience is, and hopefully it will help you out of some particular issues you may be having. So good luck to everyone, and we'll be filing some more YouTube videos here in the next week or two. So talk to you later. Have a good day.